Okay. So we'll do some questions related to the Boyle's law. So in this question, the initial volume of a gas is 500 cm cube. That's the starting volume of a gas. And its pressure is 1.1 exponent 5. So that's a starting pressure. The volume is reduced to 20 cm cube. So so this one is V1, P1, and this is the second volume, which is V2. What we need, and the temperature is kept constant, so it shows that we have to use the Boyle's law. We need a new pressure. So how to find a new pressure? So we have the formula P1 V1 equal P2 V2. So first pressure multiplied by first volume is equal to second pressure multiplied by second volume. So first pressure is 1.1 exponent 5. So we can write 1.1 into 10 power 5. Multiplied by first volume. What was the starting volume? That's 500 equal P2. The second pressure, which we don't know. And the second volume is given to 200. So it's 200 is multiplied, other side it will be divided. So it will be 1.1 into 10 power 5 multiplied by 500 divided by 200. So you will get the pressure, and that pressure will be in Pascal. So which is 275,000 Pascal. Is it clear? That's the second pressure when the gas volume is reduced to 200 cm cube. Okay. In this question, figure 6.2 shows how the air pressure in the atmosphere changes with the height. Use the figure 6.2. Figure 6.2 shows how air pressure in the atmosphere changes with the height. Like example, as we move to higher altitude, the pressure decreases. Using this, determine the pressure at the ground level. So pressure at the ground level, because as you are moving to higher altitude, the pressure of the gas is changing. What is the pressure at the ground level? Ground level means zero height. That means the ground level. So at ground level, it is 100 kilopascal. So it will be 100 and the unit is kPa, or you can also say 100,000 Pascal, because 1 kilo means 1,000. So it can be 100,000 Pascal. So if you write here, because you can see here when at the ground, the height is 0. So what is the pressure? It's 100 and the unit is kPa. What is the meaning of kPa? K means kilo. Kilo means 1,000. So actually it is 100,000 Pascal. So you can write answer in both ways. If you write here 100, then what unit you use? You use unit kilopascal. But if they say, or if you use unit Pascal, like if you use unit Pascal here, then what is the value? Then it will be 100,000 Pascal. Is it clear? Both ways are acceptable. In the next part, they're saying use figure 6.2, determine the height at which the volume of a helium in the balloon is twice at the ground compared to the ground. So what is the relation between pressure and the volume? The pressure and the volume are inversely proportional. So if volume, you need a double volume. So if you need a double volume, what should be the pressure? If the volume is double, if volume is multiplied by 2, then the pressure should be half. Because when two quantities are inversely proportional, if one is multiplied, the other one should be divided. So if volume is multiplied by 2, the pressure should be half. And how you can work out this? So original pressure was 100 kilopascal. In the question, they are asking, determine the height at which the volume of the helium in the balloon is twice. So if the volume is twice, the pressure should be half. So if original pressure at the ground level was 100 kilopascal, then it should be 50 kilopascal. So where the 50 will come, it will be between 40 and 60 and 40. So 50 will be between 40 and 60. You will draw a line and you can identify that height. Approximately each is about 200, so it will be 3,800 meters. Is it clear? Because what happened, they asked this question indirectly. They mentioned at what height the volume will be double. So if the volume is double, if a volume of the balloon is double, it means the pressure should be half. So, and we have the graph between pressure and height. So if pressure is half, so we can identify at what height the pressure will be half compared to the original. Original pressure was 100 kilopascal at the ground level. So half of 100 will be 50 kilopascal. And we are finding a volume when the pressure is 50 kilopascal. Is it clear, this example? Okay, another question related to the Boyle's law. At a ground level, the pressure of the helium in the balloon is 1 exponent 5. This is not 105, this means the power exponent. So it is 1 into 10 to the power 5 Pascal at the ground level. And it is true because that's called the atmospheric pressure, which is 100,000 Pascal. the volume occupied by the helium is 9.6 meter cube. That's the volume, so that's V1. The balloon is released and rises quickly through the atmosphere. The volume occupied by the helium increases, but the temperature does not change. So in the question, calculate the pressure of a helium when it occupied 12 meter cube. So we have the first volume. This is the first pressure, P1. We have the first volume when it is released from the ground, V1. We need a pressure when the volume is 12 meter cube. So again, we will use the formula P1 V1 equals P2 V2. So P1 is the first pressure, which is 1 exponent 5. V1, the initial volume, that's 9.6. P2, the final pressure, we don't know. And the final volume is 12. So this 12 is multiplied, other side it will be divided. So 1 exponent 5 multiplied by 9.6 divided by 12. So what we will get when you solve, it will be 80,000 Pascal. So this answer will be 80,000 Pascal. Is it clear? Okay, in this question, in an industrial process, a gas that is already at a high pressure is trapped in a large cylinder by a piston. The figure shows how the pressure and the volume of the gas vary. This one is the volume. Describe a relation shown by the graph when the between the pressure of a gas and the volume occupied. Explain this relation in terms of molecules, and it is of 3 marks. So what you will write here, because as we know, what is the relation between pressure and volume? So pressure and volume are inversely proportional to each other. So that is 1 mark. Pressure and volume are inversely proportional to each other. That's 1 mark. Then how you explain this relation? What you will say, if a gas is compressed, its volume decrease means, because you have to explain in terms of particle your answer, its volume decreases, it means particles will, or the molecules will be closer to each other, where the pressure increases means that more molecules collide with wall of container. Is it clear? This is how you get the 3 marks. One is for showing a relation. You will mention pressure and volume are inversely proportional to each other. What does it mean? It means if a gas is compressed, the volume, the space occupied by the molecule will decrease, but molecules, as the volume decreases, the molecules will collide often with the wall or frequently with the wall, so it will increase the pressure. So this is the answer which will give you 3 marks. Now, determine the volume occupied by a gas when it is released into atmosphere at a pressure of 1 or 0.1 megapascal. You will need to use the data from figure 4.2. So to get the pressure, we have the formula P1 V1 equal P2 V2. What we need a pressure, we need a volume at a pressure of 1 megapascal, 0.1 megapascal. But what is the problem here? We don't have P1 and V1. But you can use your graph to get a P1 and V1. It's up to you. You can take any value as P1 and V1. This is already in a megapascal, because the idea is that P1 V1 equal P2 V2. The final pressure is 0.1 megapascal, but what is the initial pressure and initial volume? So you can take any point on your graph. So it's up to you. Any point you can take on your graph. Example, I took this point. So this pressure, I will call that as P1. It's up to you. Any point, it's not necessary. I can take this point as well. So if I took this point, that's P1, and the relative volume will be V1. So this P1 is 10. What about V1? How you can identify? You can see between 0 and 0.1, how many boxes are there? So 10 boxes are there. So each box is representing 0.01. So 2 boxes will be 0.02. So that's V1. Is it clear? Because I want to use a formula P1 V1 equal P2 V2. In the question they ask, what is the volume when the pressure is 0.1 megapascal? But the thing is, we don't know V1 and P1 and V1. So to get P1, the first pressure and first volume, I can take any value. So I took, example, I took 10 megapascal as my first pressure. Then the first volume is, according to that, is 0.02. And just solve, it will be 10 multiplied by 0.02 divided by 0.1. What's the final answer? 10 multiplied by 0.2 is 0.2. 0.2 divided by 0.1. That's equal to 2 meter cube. So V2, the final is equals to 2 meter cube. And all of them will give you the same result. It is not depending on what point you are taking. Any point I can take, I'll get the same result. I'll show you this example. Because I want to use the formula P1 V1 equals P2 V2. So example, a student took the first point. So if a student take the first point, this is the first pressure, which is 20. And the volume at this point The volume, what's the volume of this point at this point? That's equal to 0.01. So,
01.
so first pressure is 20. First volume is 0.01. Second pressure, it's 0.1 megapascal. And V2 we don't know. When you solve this, 20 into 0.01 divided by 0.1, again what you will get, you will also get 2 meter cube. So it does not make difference to the answer. You will get the same answer if you take any point from this graph. So for the second one, why it is? Look, for the second part, between 0 and 0.1, how many boxes are there? 10 boxes. So total 10 boxes equal to 0.1. So one box or one square, because 10 is equals to 0.1, so 1 is 0.1 divided by 10. So what I'll get 0.01. That is one box. So each box, one box is equals to 0.01. Okay. An example, I took this as my first point. So if I took this as my first point, the pressure at this point is called P1. So this is P1 for us. And the volume at this point will be V1. So what will be the volume at this point when I draw a line? This volume is the first, because it's the first box, so that's V1. And we will use the formula P1 V1 equals P2 V2. I have the first pressure, which is 20. I have the first volume, which is 0.01. I have the second pressure in the cushion, 0.1. And I need a second volume. So using this, I can find the volume, which will come out 2 meter cube. Any doubt till now, this part? So Boyle's law, you will study in detail. You have to use the graph. You have to use the formula for a Boyle's law. But the second law, which is also known as the Charles law, you don't have to learn the formula for the Charles law. So according to Charles law, for a fixed mass of a gas, at constant pressure, volume of a gas is directly proportional to temperature. So Charles' law states for a fixed mass of a gas, and if we keep the pressure on the gas constant, how we can keep the pressure on the, like if we have a container, and these are all gas laws, so applied on gas only. We have a container which is filled with a gas. These are the gas molecules. And I'm pushing the container with a pressure of say 100 Pascal. This is the pressure which we applied. Then what I'm doing, I'm start heating it. At the same time, it was originally example at 20 degrees centigrade. But the SI unit of temperature is Kelvin. So you should always use temperature in Kelvin. How to convert degree centigrade into Kelvin? So you will add 273 because temperature in the Kelvin is equals to temperature in degree centigrade plus 273. So this will be 20 plus 273, which is equals to 293 Kelvin. Because the SI unit of temperature is Kelvin, so the temperature should be in Kelvin, according to SI units. 20 degrees centigrade, which is also equivalent to 293 Kelvin. I am supplying a heat energy. As I supply the heat energy, what will happen to the speed of the molecule? I am supplying a heat energy. What will happen to the speed of the molecule? So the speed of the molecule will increase. So as the speed of the molecule will increase, they will push this piston up. Now new position of the piston, because I did not change my pressure. My pressure on the gas remain 100 Pascal. I did not change my pressure, but what happened as I supply the heat energy, the particle will move faster. As the particle will move faster, they will push the piston up. So as they push the piston up and the temperature increases, so as I increase the temperature, they push the piston and move away from each other. So what happened to volume here? What happened to volume when we compare the volume of A with volume of B, the second one? So because you're increasing a temperature, so as you increase the temperature, so what happened? The molecules will push the pistons. Piston here is they're moving faster. So as they push the piston, the volume will increase. So you can see here, increasing a temperature is increasing the volume of a gas. The second one will have a higher volume, and that is the Charles law. Charles law states if you increase the temperature, the volume of the gas will also increase. Is it clear? The concept of Charles law. So volume and temperature are directly proportional to each other. So for Charles law, you don't have to learn the formula. There's a formula for Charles law, but you don't have to learn that formula. And when you sketch a graph, you should understand the concept of the graph, that volume and temperature are directly proportional. So if the temperature why we cannot use a Boyle's law here? Because for a Boyle's law is applicable when the temperature is constant. But here you are changing the temperature. And the gas will, look what happened, you are supplying heat energy, the gas molecule will hit the wall harder, they will push the piston. But if it is stop at this point, if the gas molecule stop at this point, like they're not further pushing the piston, so what does it mean? It means the pressure of the gas, again it becomes 100 Pascal. Otherwise, if the outside pressure is more, the gas will be compressed. If the inside pressure is more, the gas will expand. But if the pressure is same, it means the gas is not expanding. So in the beginning, at the beginning of this experiment, the pressure was same. You supply heat energy, the gas molecule push, and they will stop after some time. When it is stop after some time, it means the pressure is again 100 Pascal. So if the pressure remains same before and after, if we increase the temperature, the volume will also increase. So it should have a like 3 phases here. So it will have 3 phases. Number 1, when you did not supply heat energy, there are gas molecules or particles. All the cases you are applying 100 Pascal, okay? The gas molecule, and it was in the beginning, this is the position of the piston. That's start. So if this is the beginning, it means the pressure from inside and the pressure from outside is same, because it is not going down or going up. It is remain at its position. So outside pressure and inside pressure is same. Now what you did, you start heating it. When you start heating it, then the gas molecule will hit the wall, hit the piston, because piston is a movable part only. The walls or the base of a container cannot be moved. So these gas molecule push the piston. So as these gas molecule push the piston, we will reach a certain point where they will stop further increase. So when they stop further increase, it means again that the outside pressure and inside pressure is again same 100 Pascals. So both, this is the beginning and this is the start. Both have the same pressure, but what happened? Increasing a temperature will increase the volume of the gas. Is it clear? So this is a Charles law, which state pressure, volume and temperature are directly proportional to each other. Then the similar law is there, which is called a pressure law. So according to pressure law, for a fixed mass at constant volume, means volume is not changing or volume of is constant, pressure is directly proportional to temperature. So if we keep the volume of the container fixed, if like it's a rigid container means the container cannot change its shape. Like example, the gas cylinders which you are using for cooking gas for purpose or domestic fuel, these gas containers are rigid. Rigid means they cannot change the shape. So what happened? It is fixed. It is having a gas particles inside. So if the temperature increases, if I supply heat energy, so what happened? As we increase the temperature, the molecule will move faster. They will hit the wall much harder or they will move faster. So volume is kept constant. How the volume is kept constant? Because it is a rigid container. The term rigid means it cannot change its shape, size or volume. So if the volume of a container cannot change and we supply the heat energy, so what happens? The molecules will move faster and they hit the wall harder and frequently. So this will result in increase in pressure, or the pressure exerted by the gas molecule will increase. So this is a third law which is also called a pressure law. What state? It state pressure and temperature are directly proportional to each other. So in a Boyle's law, temperature is constant. In a Charles law, pressure is constant. In a pressure law, volume is constant. So for a fixed mass at a constant volume, pressure is directly proportional to increase in temperature. Any doubt related to this? Pressure law. So these are the laws. The theory is important for the other laws. And for Boyle's law, you should learn the formula.